let us solve the numerical of hyperbola. This is the first numerical of hyperbola. Is the simple sort of numericals are here. So we have to find the coordinates of the foci and the vertices, the eccentricity and the length of the lattice rectum of the hyperbola. So here we see that how we get the coordinates of hyperbola and vertices. First of all, we use look here. There are two equations of hyperbola here. One is thus uh, these two are the standard form of the hyperbola, where the center lie at the origin. Here you see in this figure, and here you see the hyperbola first equation, x square upon a square minus y square upon b square is equal to 1. The other one is conjugate hyperbola. If we have, then the x square upon a square would be negative and y square over b square would be positive. So here you see, if we compare the both the equation, we get it is the first type of equation is this x square upon a square x square upon 9, which is positive. Here also x square over a square is positive. So this is the first type of equation we have here. So we know that this one is the we have to compare with this equation. So here we see that a square is equal to 9. So a is equal to 3 now, and b square is equal to 27. Therefore b is equal to 3 root 3. Just a moment. It is 3 root 3. Now first of all, we have to find the coordinates of the foci. The coordinates of foci you see here, it is I change the color. Here you see plus minus a comma 0, or where a is equal to c. You look here. So this is a is equal to c. So we have to find out c first. So how we will get c? We know already in previous explanation of hyperbola. In my previous video, I have explained about the relationship between a, b and c. So this relationship is, I change the color here again because we are doing something else. So c square is equal to a square plus b square. This we know that. So we will do here, first thing we will put the values. A square is 9 and b square is 27. So it will become c square is equal to 36. Therefore if we take the square root of both the sides, we will get c is equal to 6. So plus minus 6, but we will get only the positive value here. It is the distance. Now we have to use as a distance. So c is 6. Now we know that the coordinates of foci, and we can take here, if we have to find out the coordinates, we don't have to use like a distance. Then we will use like plus minus 6. So it is plus minus 6 to the coordinates of foci. Therefore the coordinates of foci are plus minus c0, because it is plus minus c comma 0. So it is plus minus 6 comma 0. So this would be the coordinate of foci. So in this way we could easily find out the coordinates of foci. Now we have to find out the coordinate of vertices. Coordinates of vertices, you see here the coordinate of vertices are plus minus a comma 0. A we have 3 here. So we will write here, therefore the coordinates of vertices are plus minus 3 0, because these coordinates are, we know that plus minus a comma 0, here we have seen here, so we have to just put the value. So these are the coordinates of vertices. Now we see the eccentricity. We have to find out the eccentricity. I have previously explained in my previous video that eccentricity is equal to, because eccentricity is equal to C upon A, because you see here a square plus b square is equal to c square. If we take the square root of this, it would be c, and square root of a square is a, so we will get c upon a here. So therefore eccentricity is equal to c. We know that c is 6, and a, we have to take the positive values here, or both the negative values or both the positive value. We are taking only the positive value here, so 6 by 3. So the eccentricity is 2 here. So the it is confirmation. We are doing, we are on the right path, because the eccentricity of hyperbola is greater than 1. So it is greater than 1, therefore we have got the eccentricity here. Now we see the next thing what we have to find out: length of latus rectum. Length of latus rectum of hyperbola, because length of latus rectum of hyperbola is equal to, you see here, I explain you, 2b square upon a. This is the length of hyperbola, and b square we have 27 and a is 3. So 2b square upon a we have to put here, because 2b square upon a, therefore the length of latus rectum is equal to 2b square is 27 and a is 3. So now we see that 3 1 times, 3 9 times 27, and we get here 18. 2 into 9, which will become 18. So in this way we could easily find out the component of the hyperbola. The equation of the hyperbola is given, the standard form is given to us. First we compare that standard form with this, which sort of form is like this: if the x square over a square is positive or negative. If it is positive, then we have to follow this parameters for solving out the required things, whatever they want. If they want about to ask the directrix, so just you have to put here plus minus a upon e. We have sorted out, there are 2, a is 2 and no, sorry, e is 2, we have found it out, and a is 3. So 3 by 2 is plus minus 3 by 2 would be the equation of the directrix, plus minus 3 over 2. So center is already O, and if we have to find out the length of the conjugate axis, length of the conjugate axis would be 2b. b is here 3 root 3, so it would be 6 root 3. And if we have to find out the transverse axis, that is 2a is equal to 3, so 2a is equal to 6. So the equation of the transverse axis y is equal to 0, all is in the standard form of hyperbola, where the principal axis lies on along the x-axis and the center lie on origin. and the equation of the conjugate axis is x is equal to 0, which is the y axis here you see here in this figure. And if we have known each and everything here through this, and focal distance of any point x y, you have a point, or we have to find the focal distance of a point. If you have to find out, then ex plus minus a would be the focal distance of a point. So in this way we could easily solve the problem if the equation is given to us of hyperbola.